In this lesson, we will graph exponential functions. Before we graph, it's important to sort of understand what the graph should look like. So an exponential function obviously is in the form f of x equals b to the x, where b is greater than 0, that means our base is greater than 0, and b does not equal 1, because if you take 1 to any power, it's just 1, so we don't worry about that one. The graph has the following properties. So it's smooth and continuous. The domain is all real numbers, which means we can plug in any value for x, but the y values that will come out will all be greater than 0. And the graph will pass through the point 0, 1, unless, of course, there is a transformation of that function, which we'll talk about later. As you can see, I've sort of separated it out for you. If b is less than 1 but greater than 0, then the graph is going to decrease. F of x will approach positive infinity on the left, and on the right, it's going to approach the x-axis, which means it's going to look kind of like this. So on the left, it's increasing forever. On the right, it's getting closer to 0. If b is greater than 1, then the graph is increasing. F of x will approach 0 on the left and positive infinity on the right, which means the other one will look more like this. 0 on the left, positive infinity on the right. Both are exponential functions. It just depends on what that value is. So we're going to graph a couple of these. Again, what we're doing is we're taking the x value that we've just made up and we're plugging it in. So here, if I'm finding f of negative 3, that means 2 to the negative 3, which of course means 1 over 2 to the third, because that's what that negative value means, which is 1/8. So negative 3, we're at 1/8, which is 0.125. F of negative 2 means 2 to the negative 2, or 1 over 2 squared, which is 1/4, which is 0.25. If I plug in negative 1, that's 2 to the negative 1, which is 1 over 2, 1/2, which is 0.5. If I plug in 0, I have 2 to the 0. We haven't talked much about this in this term yet, but 2 to the 0, or anything to the 0 power, is 1. Then, of course, I have 2 to the first, which is 2, 2 squared, which is 4, and 2 to the third, which would be 8. So now I'm going to plot those points. Negative 3 is just barely above that line. Negative 2, comma, 0.25. Negative 1, comma, 0.5. 0, comma 1, excuse me, 0, comma 1. 1, comma 2. 2, comma 4. And 3, comma 8. So we can see on this side, oh goodness, just pretend I hit most of those points. Essentially, that's what my graph will look like. So it's increasing as I move to the right because this value was, of course, greater than 1. Another similar one for us to try. Again, notice that this is between 0 and 1, so this one should be a decreasing function. So if I take 1/3 to the negative 3, that means I'm taking 3 to the third, which is 27. So that one's not even going to make it on my graph because it's off of my graph. If I plug in negative 2, I get 1/3 to the negative 2. That negative flips it, so it's 3 squared, which is 9. So negative 2, 9 is a good point to plot. 1/3 to the negative 1 means basically 3 to the first, which is 3. If I plug in 0, I get 1, because anything to the 0 power is 1. So remember before, we talked about the fact that the graph should always go through at 0, 1, unless there's some sort of transformation. 1/3 to the first power is just 1/3. So 1, comma 1/3, somewhere in there. 1/3 squared would be 1/9, which is very, very close to 0. And then, of course, 1/3 cubed is 1/27, which is even closer. So as we said before, it's going to get closer and closer to 0. I did a little better job on that one, but that's essentially what our graph would look like. Go ahead and do this one on your own, and then press play to check your work. So again, I've got 3 to the negative 3, which means 1 over 3 to the third, so 1/27th, a very teeny tiny number. I've got 3 to the negative 2, which would be 1 over 3 squared, or 1 over 9. Again, very small number. 3 to the negative 1 would be 1/3. Pretty small number still. Anything to the 0 power is 1. If I plug in a 1, that's 3 to the first, which is 3. So 1, 3. 3 squared is 9. And again, that last value is not going to work because it's going to be way off my graph. So it should look something like that.